Okay, this question asked us to draw the reaction mechanism for the anti-Markovnikov hydrohalogenation reaction. Now, we learned this reaction when we talked about alkenes. We didn't explain the mechanism because we said we're going to need to wait until we get into talking about radicals for that. And so we do now have the understanding of radical mechanisms that we can explain this one. Now, there's going to be an initiation step that involves the peroxide, and that's what's going on. Remember, this reaction doesn't work unless it's in the presence of peroxide. So that UV light will give us the initiation that we need to form two OR radicals. And now I'm trying to make these fish hooks look really fish hooky, but they're kind of a harder arrow to draw. And so what do I end up with then? I end up with some RO dot, and that's the radical that I have. And so that was the initiation step. And what's next then? Okay, well, what's next is that RO will then react with HBr to form some radicals as well. So let's take a look and see how that works. So I'm going to form a bond to make the alcohol from the OR group, and then I'm going to have a bromine radical. And so let's go ahead and finish out what that reaction would provide. So now I've got a Br radical. Okay, it's the Br radical now that can react with the alkene. And so the alkene can come out and make a bond with the bromine radical, and then I have two choices. I can form a radical on that carbon, or I can form a radical on that carbon. And so which carbon is it that's going to form the radical? Well, of course, it's going to be the more stable carbon. And so this is what explains the anti-Markovnikov addition of the Br, is because in this step, we are forming a radical, and that radical wants to be the most stable radical, just like it would in the Markovnikov addition, where we're going to form an intermediate carbocation. Okay, and so now we've got an HBr that can come around, and this again is just another propagation step. I can make a bond with the hydrogen, and that can actually form my final product. And then I've got another Br around that can go in and do some more reacting. And so, you know, that what's the termination? Well, here's one possible termination step. A bromine radical can get together with another bromine radical and form Br2. There's other possible termination steps that can happen, but that's just one example. Okay. Oh, I forgot to put my Br down here. So yep, the Br is still there. And this is the mechanism that explains this. And we're using these fish hook arrows because remember, in a radical mechanism, we're talking about the movement of one electron.